Hello all, welcome to this online recording sessions in data science. So in this session, we are going to see one of the deep learning concept, that is convolutional neural network. Okay, so there are many different categories in deep learning like ANN, CNN, RNN, GANs, LSTM, GRU, right? So CNN is one of the most important concept in deep learning, which is related to mostly images. So let us see one by one what are the steps of implementation and how the working procedure will be in CNN. Okay, CNN concept, where it is used mostly in image processing. So image processing, we will use CNN concept like resizing image, filtering image, uh, extracting, applying filters to the images. All those comes under image processing. Okay, cropping everything. So next one is one of the application of CNN is computer vision. So in computer vision, what we will do, we will enable computers to think like a human and respond it like a human. Okay, so yeah, if you look into this slide, if you look into this slide, so what comes into your mind? So what you are expecting, right? So one may see two faces are, two different persons are interacting with each other or looking at each other, right? And some people may see flower vase. It is like somewhat like flower vase. If you see this white color portion, right? If you see this white color portion, you'll observe it is at somewhat like a flower vase. And if you observe black color portions, you find two different people are interacting with each other. So now you tell me how the machine should understand, whether the machine should trace out the only white portions and react to it, or whether the machine should consider only the black positions and figure out that to be as image. Okay, so that is a somewhat consideration in our CNN concept. Okay, and if you see one more image also similar to this uh, similar to this uh, similar to this concept, or similar to this the contradiction what we are trying to do. Okay, yeah, in this image you see, if I ask you how many birds are there, how you will respond? You will respond one, some may respond two. Okay, so but the actual image is this one. Okay, the actual the bird, there is only one bird, that is this one, but some people will tell two, but that is not actually the true image of the bird. It is the actually the leaves that is projecting to be as a bird. Okay, so all these cases need to be considered while we are learning convolutional neural network, because we humans can find out whether it is a true image or false image, or it is different image. But it is the machine should understand, right? It should understand depending upon the patterns, depending upon the color, depending upon the various features. The machine should be trained and the machine should learn. Okay, so that's why in our earlier days also, when say suppose LKG student or 1 year or 2 year kid learning some languages, English alphabets. So if we ask them to point, if we point to one particular alphabet and ask them, how do they respond? They respond correctly? No, right? We can't expect until and unless he is perfectly trained or he is perfectly taught. If I ask him what is the letter of this, he may respond G, he may respond A, he may respond, he or she may respond B, or whatever the alphabet it may be. Okay, so here what conclusion or what takeaway we can take is, uh, the person should be trained. That means our neuron or the particular person who is trying to understand or who is trying to learn, he should be trained. Like, he should be trained, this is G. If I anytime this letter will appear, it is called to be as G, not the other letter. Okay, so in this way the humans need to be trained and try to remember the things. So later on, we can, whenever we ask, we can recognize them and we can answer them. Okay, similarly, Machine also need to be trained. Machine also need to be trained perfectly until and unless it is able to recognize that particular image. Okay, it should be trained. Okay, so depending upon the previous cases, a bird and the flower was, we need to keep in mind in that we need the training should happen in such a way that until and unless the human or the particular model will be able to recognize properly after training. Yeah. So here, so what about the computer CNN? What about the image CNN learning? How it will happen? The CNN learning will happen by considering the image into features. Okay. So what are features? The features are the parts. The features may be eye, nose, legs, hands, or ears. So whatever may be. So these are some features. Okay. So all those things are represented in the form of grayscale. Okay, in the form of grayscale image. Okay, so that grayscale image will be in the range of 0 to 255 ranges. In the terms of pixels, the image is represented, the value ranges from 0 to 255. So if I consider this part, this may be the mouth, or this may be some part, some feature of this particular image. So see how it is represented in the form of pixels. Okay, so if I train this model and if I try to give random images, it may predict 80% has to be cat, 15% to be appearing like a dog, or 2% appearing somewhat like a hat, 1% appearing like a mug, depending upon the size, depending upon the color, or whatever it may be. Okay, so the here the takeaway is we are considering the particular features in order to train the model properly. Okay, so all those will range from the all those image value ranges from 0 to 255 scale. Okay, yeah. So what about the computer and CNN learning? How does this happens? Okay, so that means it is like a black box. Okay, so what is black box and white box? What these terminologies mean in deep learning? So black box is the one that happens internally. Okay, we can't see how it is happening, the internal procedure and all. White box is the one that is visible to humans. Okay, invisible. Say suppose, consider me. So how I am looking, how I am smiling, how I am reading, or how I am physically, what you can see in me, that is like a white box because you can see it. But internally, imagine how my stomach is digesting, how my liver is digesting, how my internal organs are responding. Are you able to see it? No, right? But internally, they're performing some actions inside, okay, which we cannot see. So that situation, that uh, scenario is called to be as black box. Okay, in black box, we cannot see internally what is happening, but the theoretical procedure will happen in internally, which is invisible. But in case of white box, it is visible, clearly visible, how training is happening, how testing is happening, how the neurons are given, how the image is getting processed step by step, we can see it. But here we need to consider black box, CNN to be as black box, where the things will happen internally which we cannot see it, but we can see the concepts that will happen in this black box which are invisible. Okay, there are some steps. Yeah, these are the some steps. The very first step is convolution. Okay, so what is convolution? How the convolutional layers are will be there. So how the one can uh, divide the convolution, one can extract convolution. Then the second step is pooling. Okay, so what is pooling, what are different types of pooling, when to apply that particular type of pooling, what is the most widely used pooling technique, that we can see. Okay, so this is second step. The first step is converting the image into convolutional, second step is pooling, third step is flattening. Okay, so what is flattening, also we can see it. So we will convert all those things into 1D array. So all the convolutions after applying pooling, so we'll be converting into 1D array, that which is nothing but a one particular image. Okay, that is flattening. So fully connected, it is nothing but all flattening layers will be giving as a uh, giving as an order, chronological order, such a way that they will look as a neuron. Okay, so all these things we will see step by step in the coming slides. Okay, the very first step is convolution. So you observe this input image, what you're trying to notice. Are you able to see anything? So I am noting down the ones which are there. So zeros are blacks. Generally in image zeros are empty. Okay, one we can represent is as non-empty, or some image is there. One or any range between 0 to 255 will be there. So if that value is there, we need to consider there is an image in that pixel area. Okay, so in this image, you see where the actual image is located. Here you can see. Yeah, if you consider all these, this is the one beautiful image of smiling face. Okay, this is a beautiful image of smiling face, which I have given as an input to the input to this deep learning model. So but how the system is considering, it is considering in the form of zeros and ones. Okay, if it considers in zeros and ones, it will be appearing the earlier ones, like, okay, like this, the smiley face, the model will internally recognize like this. Okay, okay, so now to this input image we are applying feature detector. Okay, so what is this feature detector? Okay, so it is 3 cross 3. So this 3 cross 3, this 3 cross 3 will be applied on this input image. Okay, to this 3 cross 3. Okay, so now you multiply, so 0 into 0. Okay, this, there are 3 rows, 3 columns in input image. Okay, we have considered this. So in feature detector also it is 3 cross 3. Okay, so now you multiply the corresponding elements, 0 into 0, 0, 0, 0. So 1 into 0, 0. So 1 into 0, 0, 0 into 1, 0, 0 into 0. So all will be 0. Okay, okay, so let us calculate by applying remaining to remaining ones also. So to the entire image, if we apply, what happens, we will see it by taking one example. Okay, yeah, you see here, this is a feature map. After applying this feature detector, I will be collecting the hair sample. So if I apply for this one, what I am getting, if I multiply this, all those things which feature detector, what I am getting, the whole thing will be 0, because 0, 0 into 0, 0, 0 into 0, 0, plus 0 into 0, 0, plus 1 into 0, 0, plus 1 into 0, 0. So all those, if you multiply, it will be 0 only. Okay, so that's why I'm putting here 0. Next, here two important concepts will be coming, that is stride. Okay, stride and padding. So what is this stride and padding? Now we are going to see. Okay, what is this stride and padding? So stride and padding is nothing but, so I have completed applying this feature detector to one layer, right? So if I want to apply this to another one, so if I want to get this output, so what I need to do, if my stride is 1, so then what can I do? I will take this. I'll take this one. Okay. Now I will take this one, this 3 cross 3. Okay. And again, I will be doing multiplication with this feature detector. Now you tell me, so zeros, all zeros are there. So I will get 0 only. So here 1 is there and here 1 is there. So what I will get here? I will get 1 here because 1 is here, 1 is here. Remaining all are zeros. Okay. So this is stride. Stride means, so what next input image, what with what feature detector you are multiplying in case of input image. If the stride is 2, then how you will do? If the stride is 2, stride is 1, this is the case. If stride is 2, what is the case? We will consider the second one. Okay. So now previously we have considered this, right? Now we will consider this one. So this 3 cross 3. That means we will be incrementing 2. Okay. So we'll be incrementing 2. If the stride is 3, we'll be incrementing 3 and consider the next sequence of the input image and apply this feature detector, multiply them and fill this feature map. Okay. So this is what the stride means. So depending upon the stride, we will consider the input area. Okay. Then what is padding? Padding. So if stride is 2, as said, I'll be considering this area, right, in input image. So what about the remaining part of the image? With what values are there? So some are there with 1s, some are there with 0s, right? So then padding, if padding is 0, all will be zeros. If padding is 1, remaining part of the images, irrespective of the consider image, will be the padding value. If the padding is 0, all the values will be zeros. If the padding is 1, all the values will be 1. Non-considerable area. Okay, non-considerable area will be with the padding value. So if my padding is value, it will be like this. So we will consider only this box. If the padding is 1, so all the non-considerable area of the image will be 1. Okay, you understood, I hope. Okay, what is stride? Stride is nothing but what increment we will be doing in order to consider the next area of the image. Padding is nothing but what is the non-considerable area with what values you are trying to fill it, whether you are trying to leave it empty, whether we are trying to put all values as zeros, other value you are putting some random values, it is padding. Okay, so stride and padding will be happening in this feature detector. So you now next with padding is with stride equal to 1, so what will be the next output? You tell me. Stride equal to 1. So I got this. So now next will be this 3 cross 3. Now you tell me all zeros are there, so it will be 0. Next with the next stride equal to 1, what case? This will be the case, right? So here what will be the image? So here what will be the feature map value? Here it will also be 0. Okay, so in next case it will also 0. So you try to implement like this. Okay, so after completing all those things, after completing this 3 cross 3, you come to here, stride equal to 1, right? So you increment there with 1, so you'll get this area and you fill here. Okay, so like this you try to fill all the values in feature map. So finally what you will get? Let us see. Okay, let us see finally what we'll get with stride equal to 1. We'll get somewhat like this. Okay, yeah, this is input image. Yeah, it is not there in my slide, I think. Okay, this is input image. So all those will be up after applying feature detector, it will be in the form of feature map. Okay, yeah, these all are the feature maps that you can see. So this first feature map will be from this one and this one. So if I consider for the entire image, there will be many feature maps that will be coming. Okay, then next we will be applying ReLU activation functions in order to decrease the linearity in the image. Linearity means the sharpness of the image. It is optional, we can give or we cannot give. We will apply ReLU to this feature maps after applying the convolution. This is the first step in CNN. Okay, so next step what we will do, yeah, this is the one example also. You can check it, you can open it, here you can visualize the CNN part, how it will be. Okay, so if I take this part which I have highlighted is nothing but it is coming here, right? If I take this part, the red color box in the image is appearing here. So in this using this link, you can study what value it is giving for this. So what value it is giving for this 34, right? So what value is giving for eyes within 0 to 255? You can study those values using this setosa.io. Okay, this in this link you can experiment by giving the input image. So here also you can apply different filters. Okay, Sobel filter, left Sobel. So all those filters you can apply. You can sharpen the image. So what values will get, all those things you can know this. Okay, so what happens if I apply different filters also, you can see it. So let us consider this technique by applying taking an image. You can take it. Okay, so I can take it from my CPU. From my system I have taken one image. So it will be like this. Okay, so -1 0. So this entire image is represented like this. So if I take another image, so will I get the same values or different values? Different values, right? So let us see what happens if I take different image. I'll get different values. Okay, yeah, you'll get different values. So if we take different images and we'll get different values, and you can visualize what values we are getting in particular thing. All those things we can see it in this link. Okay, yeah, now let us come back. We have finished first step, right? Now let us go to second step. Second step is pooling. So what is pooling? How many types of pooling? We have min, max, min pooling. Okay, max pooling, average pooling. Okay, so out of all these pooling techniques, max pooling is the technique that is mostly used by most of the uh, industry applications. Okay, so pooling is another building block of CNN. Its function is to progressively reduce the size of the representation. Okay, it will reduce the size. Okay, so if I apply pooling, max pooling to this, what I will get? So it is 3 cross 3, right? So we'll consider 3 cross 3. We'll consider 3 cross 3, this one. So we'll consider 3 cross 3, this one, and apply pooling. So what we'll get? What is the maximum value here? 1, right? So 1 we'll get. So with stride equal to 1, we'll get maximum value as 2. So with stride equal to 1 again, we'll get maximum value in this area is 1. So in that way, you can will this pooled feature map. So previously we got feature map, now we are getting pooled feature map. So max pooling is that. Okay. So what if I apply maximum value? Max pooling means we will take maximum value out of the consider input values of the image. Yeah. See this case. If I apply average pooling, what will happen? So 1, 3, 1, 3. So what is the average of all this? It will be 2. So 3 plus 1, 4, 5, 6, 7, 8. 8 by 8 divided by 4. How much is the average? 8 divided by 4. If I summed it all this, I'll get 8. Okay. So divided by number of values by 4, right? We'll get 2. So that's why I consider 2 here. So with stride equal to 1, again if you apply 3, 5, 10. 10 by 4, how much? Roughly 10 by 4, it will be again 2 point some decimal value. So that I will round it up to 3. Okay. Okay. I think stride equal to 2 I have taken. Okay. So, but on the whole, I am trying to convey you that it will be an average if you are taking average pooling. If you are taking maximum pool, maximum value will be displayed here. Okay. If the maximum value out of this is with stride equal to 2, 4. Okay. With stride equal to 2, this one 8. So in this way, pooling will happen. Okay. Max pooling, min pooling, and average pooling. Okay. So next step is flattening, right? So what is flattening? Converting all the pooled feature map into one dimension. Okay. Yeah. This is pooling. So this is first step and this is the second step. So we have reduced the features. Okay. Feature size. There are 2 features or some more features in this convolutional layer, but those features what are important that we are taking by applying pooling layer, and we are getting these feature maps. Okay. We have applied ReLU in between this. Okay. So next step, flattening. Okay. So in flattening, we'll converting the data into one dimensional array in order to for inputting it to the next layer. Okay. So for inputting it to the next layer, we will convert into one dimensional array. So we are having like this, right? So all this will be converted into one dimensional. If I consider all this into one dimensional, I'll get single feature map. Okay. Which is nothing but which look like a one neuron. Okay. So for n values, I'll get n neurons. So for n pooling layers, how many I will get? How many flattened layers I will get? N flattened layers. So n flattened layers is nothing but n neurons. N neurons I'll get it. So you can see it. You can see it. So you can see it. Yeah. After applying flattening layer, so if there are n pooling layers, we'll get n flattening layers. Okay. So after converting into one dimension, which are nothing but which looks like a neuron, our neuron. Okay. This is third step in CNN. So what is the fourth step? Fully connected network. Okay. So we got neurons, right? So we in a similar way we can construct hidden layers and output layers also, right? Right. So all together, if you represent how it looks like this. So after flattening, we got like this. Okay. N flattened layers. So these are hidden layers. Hidden layer 1, hidden layer 2, and this is output. Okay. So see, this is the last step in the CNN. That is nothing but a fully connected network, which is appearing like a neurons. Okay, with hidden layers, input layers, and output layers. Okay. Yeah. See, you can see like this. So that's it for this concept. I hope you understood this concept, like first step is convolutional, second step is pooling, third step is flattening, and fourth step is fully connected network in CNN. So these are the 4 steps that will happening in the CNN. I hope you understood. So thank you all. Thank you for giving this opportunity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.